In the last section, we saw that when we're talking about a span of vectors, sometimes our spanning set contains more information than we need, more vectors than we need to describe the space that we're spanning. Let me give you a quick example just to show you what I mean. So let's consider the span of the vectors 1, 1, 1, 0, and 2, 5. Okay. Now, this spanning set, it spans a plane, but we only need 2 different directions to be able to go anywhere on a plane. So all I really need is this vector and this vector. This vector is more information than I need. It's extra. Okay? And we could see that because we can describe this direction, this vector, using just these other 2 vectors. Okay? So let's note that 2, 5 is equal to 5 times my first vector, 1, 1, minus 3 times my second vector, 1, 0. Okay? Which means this vector can be expressed as a linear combination of the other 2 vectors. And so it's not really contributing anything new, because anywhere that I could get with this vector, I can also get with these 2 vectors. Okay? Thus, this span that we're talking about here span of the vectors 1, 1 and 1, 0 and 2, 5 I can take this vector out of my spanning set of vectors and I would still have the same span. So this vector here, it's really not giving us any additional information. It's not being especially useful here. It's redundant. Okay? Let's define this idea properly. So let's let V1, V2, all the way to Vk be a set of vectors in Rn. If we can remove one vector without changing the span, we say that vector is redundant. And let's be more specific here. That is, if we take the span of these vectors from V1, V2, all the way to the last vector. But let's describe some of these vectors in between because they're going to be useful here. So some of these vectors in between, let's say Vj minus 1 and Vj and Vj plus 1, and then we go all the way to Vk. Okay, so we're just highlighting some of the vectors somewhere in the middle there. Doesn't matter which one. But say we are able to take one of them out, and we still have the same span. So if we just take that jth vector out, whatever j is, then we say that particular vector, bj, is a redundant element. Well, let's just say is redundant. Okay, if we can do that, if we can take it out of the span, it's not contributing anything to the span. It's not giving us any new information. And so it's redundant. It's not helpful. And so by taking it out, we are able to describe the same space with fewer vectors. Okay, going back to our example up here, in this case, the vector 2, 5 is a redundant vector. I am able to take this vector out, and the span of the remaining vectors spans the same space. This is redundant because it's not giving us any additional information beyond what these first two vectors are giving us. Okay?